Welcome to the Unreally Impressive Coder, where we transform aspiring engineers into tech giants one tutorial at a time. Join me as we dive deep into the world of FAAng interviews, demystifying the process and giving you the edge you need. Together we'll conquer data structures and algorithms, ensuring you have the skills to tackle any challenge thrown your way. We'll also explore competitive programming techniques, sharpening your problem-solving abilities and preparing you for coding competitions. In addition, you'll learn essential programming languages through engaging tutorials that cater to all skill levels. Understanding the nth root of a number is essential for programmers, as it can present both challenges and fascinating solutions in coding. In today's video, we will explore what the nth root is and how it can be implemented in various programming languages. We'll start by breaking down the mathematical principles behind finding the nth root of a number. Next, we will discuss common algorithms used to calculate the nth root efficiently. We'll also address potential pitfalls and edge cases that programmers should be aware of when implementing these calculations.
Now let's implement our algorithm. First, we'll have left and right pointer. So double left equals to 1.0. Since we have decimal number, so we have to use the data type a double. Now double right equals to the number x, and the error, double error, the accepted error is 0.001. Now we're going to use a while loop. While right minus left, while right minus left is less than error. Sorry, here should have greater than. If we have the error is greater than the difference of right and left, then we will have the nth root in these two variables. You can write right or left. Now inside here, now let's calculate middle. So double mid equals to left plus right divided 2. Here 2.0. Okay. Now here we're gonna check by multiplying middle n time. So let's multiply middle n time. So let's call a function here, multiply middle n times. Okay, if the multiplication of the middle n times is greater than x, then I will shift the right pointer to middle. Otherwise, I will shift the left pointer to middle. Okay, now let's implement this multiply function right below here. So private static, it will return double. So double multiply, we will multiply the mid n times. Okay, so double mid int n, we'll have n, we have to multiply n times. Okay, here n is the integer, that's what we have here, type n. Now let's create a variable answer. We'll store the multiplication of mid n times in this variable, so 1.0. Now let's run a loop for int I equals to 1, I less than equals to n, I plus plus. We're running this loop just for multiplying the mid 3 times, and we'll store in this variable. So answer equals to answer times, answer equals to answer times mid, and at the end I will return the answer. Okay, when you're done with this while loop, we will have our answer in this left variable or in this right variable. Actually in this both variable we will have the right answer, since we're allowed to have this error. Okay, 0.01%, I think. Now here, if we return left, it will work. If we return right, it will work as well. So let's return here left. It doesn't matter. Now let's run this code and let's see what's happening. If we have any issue, we'll fix. Okay, we see it passed all the test cases. This is the algorithm. Okay, this is the implementation of our algorithm. This algorithm will take big of log n time complexity, because we're dividing the number each time with n. It will take actually log 2n time complexity, And space complexity, it will take constant space complexity since you are using some variable here. When you're talking about logarithmic time complexity in computer science, we assume that is a 2-based log, right? Okay, let's mention it here. It will take a 2-based log. This is the algorithm. Hope you've understood how to solve this problem efficiently using binary search algorithm. Thanks for watching this video. I will see you in the next one.
As the video comes to a close, don't forget to subscribe to the Unreally Impressive Coder for more insights and tips to ace your coding interviews and programming skills. Thank you for joining me today, where I strive to equip you with the knowledge and tools necessary for success in software development. Remember, practice makes perfect, so be sure to apply what you've learned and keep challenging yourself. Stay tuned for our upcoming tutorials on data structures and algorithms that will sharpen your problem-solving skills. As we dive into machine learning concepts, you'll discover how to leverage AI in your projects and stand out in interviews. Don't miss out on our web and app development series where you'll learn to create stunning applications from scratch. Finally, I encourage you to engage with the community by sharing your progress and questions in the comments section below.